In this video, we'll discuss one problem from Root Locus Technique. Now consider this problem. This problem appeared in GATE ECE 2007, and it says that a unity feedback control system has an open loop transfer function g of s, this one, k upon s times s square plus 7s plus 12. The gain k, for which s equals to -1 plus j1, will lie on the root locus of the system, and 4 choices are given. So we need to find out the value for k so that this point s equal to -1 plus j1 will be on the root locus. So that is the problem, and we need to solve this one. To solve this problem, we'll start with this gain function g of s, and g of s, this one is called open loop gain function, and when this g of s is connected with unity gain feedback, then the closed loop transfer function will get it. So g of s is given by this one. Now first we'll try to find out poles and zeros of this gain function g of s. So if we can have vectors for this one, very simple one. This is square plus 7s plus 12, that can have two factors, s plus 3 and s plus 4. So from here we can easily find out open loop poles and zeros. As there is no polynomial in numerator, so there is no zeros, only we'll have poles. So solution of this one equals to 0 will give us the poles. So poles positions are s equal to 0. The second one is s plus 3 equal to 0. That means s equal to -3. This one. And this one is s plus 4 equal to 0. Means s equal to -4. So these are the three poles at 0, -3 and -4. So I'll plot these poles and zeros on S plane. This is a real axis part, and this is on imaginary axis. This is your S plane. There we'll use this cross to denote it is a poles, and we'll put circle to denote zeros. But here in this case there is no zeros, only three poles. Poles are at this point at its origin, at s equal to -3 here, and it is equal to -4. This three. Now testing point, one point is given s equal to -1 plus j1. That we need to check whether, so it should be in order on root locus. It is mentioned. We need to find out the k value for which it will be on the root locus. That is the question. So we'll consider that point. This is point is equal to -1 plus j1. So this is -1. This is your plus j1. So this point is your -1 plus j1. Okay. So this complex point. Okay. Now what I'll do, I'll first connect this point to all other poles and zeros. Okay. So here I have only three poles. So I'll connect from this point to this pole, this point to this pole, and again this point to the next pole. Okay. Then we'll try to find out the magnitude of this gain function g of s at that point. Means here it is given s equal to -1 plus j1. The meaning is that first we replace s by this value, s equals to -1 plus j1. Then we will compute the magnitude. It can become one complex function, and that one, from that one we'll get the magnitude. Okay. So in this case what I'll do, I'll consider this a function. So k is one real. So this is remain same. So from this point to this point, that's this length I need to consider. That is your SP1. If I consider P1 is this point, origin point. So distance between AS and P1, SP1, and distance from AS to P2, and again distance from AS to P3, we need to calculate, and we need to multiply these three. Then overall gain function magnitude will be k upon this 3 product. Okay, so if poles are there, we need to divide this length, and if 0 is there, we need to multiply in numerator, right? So now we'll try to find out this length. So as this length is 1, this height is also 1 because the point is -1 plus j1. So this is your length is 1, this to this, right? And this is 1. So this length sp1 should be square root of 1 square plus 1 square by Pythagoras theorem. Okay, this diagonal hypotenuse, right? Similarly, I can find out this one, this sp2. For sp2, this length I need to measure. So as it is -3, this one is -1. So this gap is 2, and height is again 1. So thus this hypotenuse will be square root of 1 square plus 2 square. Similarly, sp3 would be same height 1, so square root 1 square, but this base is 3 square, this 3, that is 3 square. So you will get this magnitude k upon, so first one is square root 1 square plus 1 square, this one is square root 1 square plus 2 square, and third one is square root 1 square plus 3 square. So if you simplify, you will get k upon, this is your square root 2, this is square root 5, this is square root 10. So again, if you multiply this square root 10, square root 10, it will become 10. So k upon 10. So this is the magnitude at that point. Now I'll try to mention what the required condition so that the S point will be on the root locus. Now I'll consider this feedback loop, unity feedback. So this is your GS open loop gain, and this feedback, there is nothing is connected, so its gain is 1. Thus it is called unity feedback control. So for this unity feedback control, the closed loop transfer function is given by Cs upon Rs equals to Gs upon 1 plus Gs. So if you want to understand this system is stable or not, we need to solve the denominator equals to 0, and that will give us closed loop poles. Okay, so for closed loop poles, we need to solve this equation 1 plus Gs equals to 0, and this is called characteristics equation. And here you see Gs is a function of k. So if you vary k, then we'll get one locus, and that locus is called root locus. Okay, so if one point is given, if that point is on the root locus or not, for that we need to check these things, that 1 plus Gs equals to 0 or not. So Gs equals to -1 we can solve, and -1 we can rewrite as its magnitude is 1, and as it is a minus value, I can write that its angle is, or phase is -180 degree, or its odd multiple. Okay, it's multiple of 3, 5, 7, like that. It could be plus minus again. Okay, not only minus, it could be also plus. So this is called phase criteria, and this is your magnitude criteria. So we need to satisfy both the things, but it is already mentioned that S will be on the root locus. That means phase criteria is already satisfied. So just we need to find out the k, because here you see k will not provide any phase. I'll assume that k is positive. So k will not provide phase. All other poles and zeros, they will provide phase. Thus phase criteria is already satisfied, we'll assume. And now we'll consider this thing only. This magnitude should be 1. So already we have got the magnitude k upon 10. So we should equate this one. K upon 10 should be equals to 1. This is the required condition. So k upon 10 equals to 1, and thus k equals to 10. So the choice D is correct. So this is the solution. I hope you can solve this kind of problem. So whenever one position, one point is given on S plane, and you need to check whether it is on the root locus or not. That time you need to check these two criteria. One is phase criteria, another one is magnitude criteria. Magnitude should be 1 and phase should be odd multiple of 180 degree plus minus sign. Okay, and if I want to find out only k, then we can work with only the magnitude criteria, because phase criteria should be satisfied, otherwise it cannot be on the root locus, right? Now I'll give you one small homework problem, this one. So this is again one feedback, negative feedback system. So this is your k, forward gain k, and this is your gs, s plus 3 upon s plus 2, and this is in the feedback loop, the gain is given 10. Now for this system, we need to find out the k value so that s equals to minus 2.7 will be on the root locus. Okay, I hope you can do that one. So what is your characteristic equation? 1 plus gs hs equals to 0. 1 plus k times this one, s plus 3 upon s plus 2 times 10, that is equals to 0. That is your characteristic equation. Then you can proceed the same approach. You can use the same approach to find the value for k and solve for k and write your answer in the comment sections, okay, if you can find out. So if this video is useful to you, then you may press like button, okay, and if you have not subscribed this channel yet, and if you want to get more such video in future, you may subscribe this channel as well. So thanks for watching.